Right, question 6 is a binomial expansion question. This is a topic that you should normally be absolutely banking on getting right. This particular question has got um, some tricky parts to it, mainly because the numbers are really large. And I think at one point, I think we even exceed the capabilities of the calculator to handle the fractions, but we'll see about that when we get there. But the process is a standard process, and you need to be able to do it. So, um, the first part of the question we're being asked to find the first four terms. In fact, it's another show that question. So they're not giving us the whole answer, but they're giving us part of the answer. That does not mean that we can just write this x cubed term down. We have to demonstrate how we get that x cubed term as well as the rest of it. Okay, I did see one or two students who worked out the expansion up to x squared and then just took the x cubed from the question. You can't do that on a show that. So let's see how this is going to work out. It is quite awkward because I must admit I've already done this a couple of times and got the wrong answer. So it's not dead straightforward to get the right answer out of this. It's just awkward calculations. So anyway, let's do it. So f of x is 10 over the square root of 4 minus 3x, which we need to immediately write as 10 4 minus 3x to the negative a half. The next step is to take out the 4. So this is 10 times, and then as we take the 4 out, it takes on the power. So it's 4 to the negative a half, and then that becomes a 1, and the 3 becomes 3 quarters x to the negative half. 4 to the negative half is 1 over the square root of 4, which is 1 over 2. So 10 times a half is 5. So this first term simplifies to 5. And then we have our 1 minus 3 quarters x to the negative half. You did get the first mark for getting the first term as being 5. So, well, with one more line, you would have got a mark for the 5. The next couple of marks come from doing the actual expansion. So let's do that now. I'm going to start over here to give myself some space. So I'm going to leave the 5 there because it does sometimes get forgotten. So I'm going to keep it there and a big bracket, and let's go with the expansion. So the first term is 1 plus, and then the power comes down, minus a half, and 3 negative 3 over 4x. Don't forget the minus. The next term, minus a half minus 3 halves. That is the n minus 1 over 2 factorial, negative 3 quarters x squared. And finally, minus a half minus 3 halves minus 5 halves over 3 factorial times negative 3 quarters x all cubed. And potentially there are more terms, but we've got our first four terms. Now, normally I prefer to try and simplify these expressions a little bit, sort of cancelling out before I get the calculator out, because, well, as I've already found, it's quite easy to make errors on the calculator. Um, there's only one thing here that really looks like it wants to cancel, which is this 3 with this 3 factorial, which is going to leave me with 2. There's really not much else that I can see. The other thing that I do like to do is to sort out the signs, as in positive and negative, because then I can forget about them when I do the calculation. So I've got negative times negative, which is plus. Here I've got negative, 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 which is also plus. And here I've got 1, 2, 3, 4, 5, 6 negatives all multiplied together, which is also plus. So having established that they're all going to be positive terms, I can now forget the all the negative symbols in there and just concentrate on the numbers. So let's actually work these out. So the first one's going to be, well, actually, I'll leave the 5 for another step. So we've got 1, and then we've got a half of 3 quarters is 3/8. So 3/8 x. The next one, I think I'm going to do on the calculator. So it's a half times 3/2 times 3/4 squared, which is 9/16. 9/16. And then I need to divide that by 2. So that is 27 over 128. So that is the x squared. And then the last one is a half. Yes, it's a half times. Now it was 3/2, but I cancelled out the 3. So it's just a half. I think that's where I went wrong before. Times 5/2. Maybe I'd be better not cancelling it. So a half times a half times 5/2, and then 3/4 cubed is 27 over 64. Okay, and then I've got to divide all of that by 2, and that is 135 over 1024. 135 over 1024 x cubed. Okay. And that's still got the 5 outside. And so now I can multiply the 5. So that's going to be 5 plus 15 over 8 x. 5 times 27 is 135 over 128 x squared. And then 5 times 135 is 675. 675 over 1024 x cubed. And that is my answer. Okay, I know at least I've got the reassurance that I've got the 675 x cubed up here. So at least I know if I was wrong, which in fact I was on my last attempt. And it was because I was doing that cancelling. I probably shouldn't have done that. Anyway, there we are. That is the correct answer. That 5's not very clear. Okay. So let's look at the next part. This is to do with the validity. Given that the expansion is valid for mod of x is less than k, state the largest value of k. That's a slightly unusual way to phrase the question. The validity of this expansion is valid for the modulus of 3x is less than 4. Or to put it another way, the modulus of x is less than 4/3. That's the way they normally express it. For some reason, they're asking us to say what k is. Well, so k could be anything as long as it's smaller than 4/3. So the largest value of k, I'll call that k max, is equal to this value 4/3. Okay. It does, I mean, I don't know why they've expressed it that way, but they have said state the largest value of k. So k, the maximum value of k is 4/3. It's not an inequality, but there we are. Right, the next part is a fairly standard sort of question where they're asking you to substitute a value in to find an approximation of a root. This is where the fractions get a little bit nasty, I think. So we're subbing in 1/3. We need to sub a third into the original function and into the approximation. So the first thing probably is to actually do the actual function. So f of 1/3 is 10 over the square root of 4 minus 3 times a third. And that is 10 over the square root of 4 minus 1, which is 10 over root 3. And that's where we're going to get our root 3 from. Now, depending on how you leave this, it does affect your answer. You might leave it like this, or you might write 10 root 3 over 3. Both are acceptable, but they do give you slightly different answers at the end. So the other part is that we are going to sub x equals 1/3 into our expansion. So that's going to give us well, it's going to give us the approximation. So if we say 10 over 1 over root 3 is approximately 5 plus 15 over 8 times a third plus 135 over 128 times 1/3 squared plus 675 over 1024 times 1/3 cubed. Now, I'm just going to pretend or hope that I didn't know that this is going to cause a problem. So I'm just going to go ahead and try and type all of that in to the calculator. There's not a huge amount. Is there anything I can do with that? I can actually do some cancelling here. Because 135 divides by 3 and 675 also divides by 3. I think I might do that. I'm just making this up as I go along now. So 15 and 3 cancels, so that is 5. What a third cancels with 135 to give 45, which goes again. So the whole thing goes to give 15. And here we've got, if I cancel one of the 3's, I get 2, 2, 5. That also divides by 3. So another third goes and I get 75. And that also divides by 3. So I get 25. Okay, well, that makes life a little bit simpler, doesn't it? So I've actually got 5 plus 5/8 plus 15 over 128 plus 25 over 1024. And yeah, my calculator handles that quite nicely. That is 5905 over 1024. Without that cancelling, I'm not sure if it works or not. There is a stage in this question where the calculator can't handle the fractions anymore and it gives it as a decimal, which you don't want. So from there, all I need to do is rearrange this. So root 3 comes upstairs and everything else goes on over to the other side. So you end up with root 3. This is approximately. Root 3 is approximately, root 3 is going to come up there, 1024. So it's going to be 10 times 1024 over 5905. So 10 times 1024 divided by 5905 is 2048 over 1181. 2048 over 1181. And that is one of the answers in the mark scheme. Okay. If you did it the other way, you'd do the same thing, but instead of 10 over root 3, you would have 10 root 3 over 3 is approximately the same fraction, hopefully, 5905 over 1024. And that would give you root 3 is approximately 5905 times 3 over 1024 times 10. And that gives you a slightly different answer, 5905 times 3 divided by 10240. And that is, now that's where the calculator gives up. So the calculator has now given me a decimal. What I could do is I could at least cancel this by 5s. So that would be 1, 1, remainder 4, 8, 1. And then that would be a 2. I wonder if it could cope with that. 1181 times 3 divided by 2048. No, it still can't cope with that for some reason. So I've got to do it by hand. So 1181 times 3 is 3543. And the denominator is 2048. And that is also in the mark scheme. That's where the calculator can't cope. Calc cannot cope. And I think that's a bit mean, really, but this is a mock paper, not a real one. I'm not sure whether that would have got through scrutiny on a real paper. But anyway, so yeah, that's the binomial distribution with a little bit of a twist. We did get the right answer in the end. I did have to have a couple of goes at it, and I can sympathise if you also struggle to get that answer out. But the process, at least, is standard. It's just that the numbers were a little bit tricky. So that was the end of question 6.